Namaste everyone. I am Saijith TM. Today, my friend Saijith Hegde is going to present a seminar on the topic vectors. So, he asked us to get into one of the premier institutes of medical sciences. Now, I invite Mr. Saijith to explain the topic vectors. The stage is yours.
Thank you, Yashas. First of all, I'd like to thank Mukesh sir, SM sir, and all the physics faculty for helping me and guiding me through this project. So, starting with vectors, let us imagine all of us sitting here are rookies and are starting from scratch and have come here for the first time. Let's start with quantities. What are physical quantities? Anything that can be measured, right? Okay, we go out, okay, now I take this chalk holder. I can measure this, there's something here in my hand. Is this a physical quantity? Yes, it can be classified as one. But when we think of something as physical quantity, there's a lot of things that come under that. So the first division comes to scalar quantities. Anything that is magnitude but no specific direction is scalar quantity. Just like distance, time, temperature and mass. But now you all might be wondering, when my topic is vectors, why am I speaking about scalar quantities and all of these physical quantities? Exactly the thing that's trickling in your head is vector quantities, the exact opposite of scalar quantities. So what are vector quantities? Anything that has magnitude and specific direction, just like displacement, force and velocity. Now that we know what vector quantity, scalar quantity is, we need something to represent these. We can generally say that my hand moving here is a vector quantity going there. We need a proper symbol for that, and that begins with a symbol. What I believe is all of the science thing is related to 8 old stories told by all our grandparents and sages. Let's go to time of Mahabharata, when Arjun took his last arrow and shot the head of his enemy. Same arrow works as a vector. Let me draw an arrow here with the point of origin known as tail or origin. Now, if this has a specific name, this also has one, followed by head or terminus. Now, with us knowing how to represent a vector and what a vector quantity is, let's move to the next stage, types of vectors. Vectors are usually classified into 8 types, starting with equal vectors. What are equal vectors? Let's take an example. I use my right hand. I apply 10 Newton of force on this board in one direction. I know it's not a large amount to shake the wall, but I use another 10 Newton from my left hand and apply it again. What have you observed? Was it just a joke done by me? Absolutely not. So what I've done here is applied force in one direction and applied another same magnitude of force in the same direction. That is what happens in equal vectors. When a magnitude or a force is applied in one same direction, it is known as equal vectors. If there's something like this, there should be an opposite also, and that is negative vectors. I would like one of the volunteer, anyone please, could you please come on stage? What's your name? Ayush. So thank you, Ayush. Good volunteering. I want you to pull me with some minimum force. Okay? Okay. So what is happening here is he's pulling me with a certain force. I'm applying the same amount of force and trying to pull him back. The force here is nullified. Thank you, Ayush. So what have you observed here? There's magnitude of force acting here which got nullified because each of us were acting in different direction. This can be represented in the following way. Where person A is pulling in the opposite direction and person B is also in the opposite direction, the force gets nullified. So now we're done with 2 types of vectors. Let's move to a third type of vector, that is null vector. Null vector is just like a person dancing. He got a lot of moves but no motor. Same way, null vector has 0 magnitude but moves in a lot of direction. We're done with 3. Let's move to the 4th one, coplanar vectors. We've all seen graphs in our 10th standard, one of the most scoring part for me, of course. So with a quadrant drawn, I take the first one, draw a vector over here and name it F1. Draw another vector over here and name it F2. What do we observe over here? They both are acting on the same plane. When one or more than one vectors act on a similar plane or a same plane, this is known as coplanar vectors. Done with 4, moving to 5th, co-initial vectors. Okay, I would want you to take this chalk, throw it on any part of the board with as much as force possible. Okay, dot detected. So this is the point that she has chosen. I pull a vector down, F1, F2, F3. Do you notice something going on over here? All the vectors are originating from one same point, and this is what is co-initial vectors, because they're initiating or starting from one similar point. Same way, I take another point over here. Let's name it point A. I draw a random vector coming from this side, this side, this side, and this side. Now what do we observe here? That all of these vectors are moving towards one same point. This is known as coterminous vector. Terminus for short stands for head, which is this part. When the head of a vector moves towards one same point, when more than one vector move towards one same point, this is known as coterminous vectors. How many have we done with? Equal, negative, null, coplanar, co-initial, coterminous. So what is the next one? Let's recap. What is the next one that comes to your brain when you think of this? That is free vector. Exactly. What happens in free vector? Let's take a vector over here, moving towards the point N. Now in free vector, the magnitude remains constant. Nothing changes. What we have to do is change its position without changing the direction. Is it possible? What most of us think, let's make it move this side, turn it, move it this side. But is it practically possible to do all of these things? Absolutely not. So to change its position, we have to move it parallelly. So what happens when we move it parallelly from point A? The vector moves to point B. The magnitude remains the same, the direction remains the same, but the position of the vector has changed. This is free vector. If you understand this, you have understood one of the best principles of physics. Moving to the last and eighth part of vector, unit vector. Unit vector can be written as a note. Any vector which has a magnitude of 1 is known as unit vector. This usually comes in handy in numericals. So, do you still need an example for free vector? Okay, I'm ready to sacrifice myself for this example. Imagine myself as a vector standing straight, moving towards the point north. My direction is decided, but I have to change my position. Is this still possible? I jump from point A to point B. What has happened here? Direction remains the same, position has changed. These are the 8 types of vectors. But have I come here only to explain these things? This could be done by anyone. Is vector only this much? Not at all. Each and everything that comes in physics has numericals, and the same applies to vectors. So what are we going to learn in the topic of vectors and numericals? Usually what comes to us is finding magnitude. Magnitude is really important. The first thing that trickles to your brain, why learn all of those things? We have scalar quantity, magnitude might be enough for us, but this is not the case here. Anything in this whole universe needs vector. We need to find the direction at any cost, and this requires magnitude, resultant, dot product, vector product. I know, let's just scratch our heads on this heavy wordings, but let's directly dive into the main topic. So let's start with magnitude. I'll represent magnitude with the letter M. Now, magnitude has the formula whole root ax square plus ay square plus az square. Okay, learning formula is really easy. Anybody could mug up. Like, I could have mugged up this whole thing long ago, and I could have written the same thing in my 5th standard. But is this really that simple? What we have to do is take a vector A. Now, the question is as follows. Calculate the magnitude for 2 I cap plus 3 j cap plus 5 k cap. Wait a minute, did I explain the fact of cap? Like, how did all of a sudden something called cap arrive on a letter? Haven't learned this in algebra, nor in alphabets. Like, what are we doing here? Am I missing out something important? Yes, dimensionality. Physics, again coming to graphs. What we have observed is two axes. One, namely the x-axis, another, namely the y-axis. What if there comes another third dimensional or third axis? Let's name it z. Now with this, we can easily correlate the topic of letters converting into cap and then having an axis on this point. The I cap represents the x-axis. The j cap represents the y-axis, and finally the k cap represents the z-axis. With this solved, we have got a glimpse of one main thing, that 2 can be substituted to x, 3 can be substituted to y, and 5 can be substituted to z. Now, can someone help me to solve this? If we go through the easy way, whole root 2 square plus 3 square plus 5 square. So what's the answer that we are getting here? Anybody please calculate and just give me the answer. The answer is 38 is exactly correct. 4 3 3 is 9 plus 25, which results in whole root 38. Okay. This was one thing that was done by me. See, there are seminars going on everywhere. People come, they teach you things and go. Let's play a game over here. Let's keep level. Magnitude being level 1, resultant level 2, dot product level 3, finally vector, the boss level, who we are going to defeat very soon. I'm going to give you a random question very soon and let's see which level you stand at. Okay, I want you to give me a number. 4, okay? Four I cap, another number 9. Another number from there 7. Okay, who can give me the answer to this question? So who can give me an answer to this question gets a round of applause. So begin fast.
4 square plus 9 square plus 2 square, which is 18 plus 18 plus 9.
And this is whole root 146. Yes. So all the warriors right here standing have cleared the round 1 and is leading to the boss level. So level 1 completed. So now moving on to the next topic. What comes after magnitude? Resultant. Resultant is something that's very repeatedly being asked when it comes to the topic of vectors. But how do we find the resultant? Resultant, which I'll represent by R here, is AB cos theta. So this is the formula for resultant. But see, as I told earlier, formula can be written by anyone. The main key here is how to solve this thing. Okay, again, as usual, any number from there. Any one number within 1 to 10. Any one person, please. 1, 8. Okay, I'll take 8 as this time. So I take A is equal to 8. Now value of B, one number. 6 again. So how do we solve this equation? A 8, B 6. So this sums up. There is a catch here. Anybody could easily substitute A8, B6, find a solution and run away from there. But the catch here is this part, cos theta. Resultant requires cos theta. Now there are two types of resultant basically, R max and R minimum. That is maximum resultant and minimum resultant. When it comes to these type of cases, we usually find the maximum resultant with the cos theta given. Now, our assign theta is equal to 60 degree. So what is, with the standard result of 146, we move on to a second topic. As I've already said, all the warriors standing here have finally cleared level 1 and are getting very close to the boss level. So here we go to the next topic, resultant. So I'll represent resultant R. So this is whole root a square plus b square plus 2ab cos theta. Okay. With this here, again, I take a value as 8 and b value as 6. Okay. So again, theta is equal to 60. Let us substitute. This results in a square. 8 square plus 6 square plus 2 into 8 into 6 into 1 by 2. Any errors? Not at all. 2 gets cancelled. 8 8s are 64. 6 6 are 36 plus 8 into 6 8s are 48 whole root 148. 60, 30, 90. I'm believing you guys at this point. Yeah, it's root 148. So this is the basic concept of resultant. See, I can solve these. The thing is, I can't build an army alone. I need a whole army to defeat the boss level. So I need you people to solve the next one as quickly as possible. Okay. Resultant A 7, B 3 cos 60. Your time begins now. Whole root 79, exactly the answer. Very, actually, to be frank, the speed is great for army. I guess we'll be very soon near the boss. Anyway, moving to the next topic. As I already mentioned, there's something called R maximum and R minimum. So what is maximum resultant and what is minimum resultant over here? Okay. What is the thing? A plus B. Exactly. But the catch is they don't give you the cost value. What do you do when they don't give you the cost value? You can easily substitute the same thing, substitute this as 0 and solve the problem. But that would be a very lengthy process. What we need to be as quick as lightning. We need to, as fast as possible, to finish this problem, to mark it on the OMR. So here we use the formula R max is equal to A plus B and R minimum A minus B. Everything is same. What we are doing is maximum value. What is maximum? When a lot of things combine together, they form the maximum value. What is minimum? When all the things start dividing and fall apart, it forms the minimum value. So here we are adding A plus B and A minus B. Okay, I'll give you a random value. A7, B3. What's R max? R max 10. What is R minimum? Very good. Okay, R max is 10, R minimum is 4. Okay, With this speed, I feel like I'm not needed here. You people already know everything. Okay, let's drop out of all of this calculation and catch some other things also. So why is vector needed? Any idea? Like we have physical quantities, we have scalar quantities. Why exactly the thing vector needed? See, physical quantity, anything that can be measured. Scalar quantity has magnitude. Why vector? The whole thing. Why at all? Anybody here? Okay. Anybody has an idea why vector is needed? Simplify the study, research. Okay, that can't be completely agreed, but the point of this and another axis, z axis, is very, very true. So vector here gives us direction, one of the most important aspects when it comes to physics. Physical quantities, as I already told, gives us the physical measure. Scalar quantities gives us the whole magnitude. But what are the direction? How do we calculate in which direction and what speed, and how do we do all of those things without the main concept of direction? That comes in when vector hits us at the straight. All in all, direction is a very important aspect. Yes or no? I ask again, yes or no? Yes. Okay, so if direction is very important, vector is also the same. So we've done a lot of things, like you know what magnitude is, you know resultant, you know how to find the maximum resultant, minimum resultant. Now we are very, very, very close to getting vectors completely in our hand. Any question from vectors, we'll solve it within minutes. Next main thing, multiplication of vectors. So who is confident that they will solve the second question just after I solve it? Right next question, after I solve one, they should be ready to solve it. I give one question, I solve it completely. The other question should be solved by you. Who is confident that they can do that? Anyone here? Excellent, great. Okay, I will solve one and you will get the chance to do the second one. So multiplication of vectors starts with dot product. There's something called dot product. Dot product, or also known as scalar product. Okay, what happens in dot product is vector A being multiplied with vector B. What does this gives us? What happens? A dot B cos theta. Sin theta comes in the vector product, also known as cross product. But when it comes to dot product or scalar product, it is A into B cos theta. So with this done, we have found one of the most fundamental things is dot product. So what are the questions that we can have when it comes to dot product? Again, as I've already told you, there exists three axes: y-axis, x-axis, another third axis named as z. So what does x represent? I cap, excellent. What does y represent? J cap, and z k cap. With this done, let me give you the first problem or the first weapon that we're going to use against our enemy. So A is equal to 2, B is equal to 3, cos 30. So this is the data given. What this usually comes, see, how are you guys so fast? I really feel very sad right now because you people are better than me over here, because I really take time solving all of those things. Yet, let's do one thing. What happens here is AB. 2 into 3. What is cos 30? Root 3 by 2 into root 3 by 2. What does this gives us? 2, 2. Amazing. Okay. Okay. You will do the second one, right? Okay. Would you like to go? Or okay, I'll give you the question. The first one to do will get a chance. Okay.